Our next topic is going to be in regards to law of sines. So far we've talked about right triangles in trigonometry, and you've just taken your quiz on that. We're also going to talk about how trigonometry can apply to any kind of triangle. Now you can ignore the 10.4 that's at the top here. This is from our old textbook. But the law of sines is still in our current textbook. Now, we only can use the law of sines in two given situations, and so far, that's all that you're going to be able to see. There is another formula that you can use to find missing angles and sides. You can use the law of sines when you have two angles and one side, or if you have two sides and an angle opposite one of the sides. As we go through the examples, you will see how these two match out. The technical formula for the law of sines and how it will appear on your formula sheets looks like this. It seems a little bit overwhelming, so I'm going to explain what it's basically saying. It's basically looking at a proportion. If I were to find the sine of angle A and look at the side opposite of it, if I were to divide these two, I would get the same solution as angle B over the side opposite of that. We choose the formula based on what information we are given. Like I was saying in the beginning, there are two key possibilities that we see for law of sines. So I'm going to work through an example of each. This is definitely a video I would suggest you go back and rewatch again just to kind of see how the pieces fall together. The way these problems show up is they're going to ask you to solve the triangle. When they ask you to solve the triangle, what they really mean is, can you find all of the angles and the sides? This is the easiest scenario because we can easily find the missing angle, and we already know how to do that. To find the missing angle, all I really need to do is take 180, subtract 100, subtract 33, and I can find that the missing angle is 47 degrees. Not a very complicated thing that we need to do, and that's one of the three pieces we need. Now in step 2, that's where we're going to start to see how to use the law of sines. Let me first show you how I set up the problem, and I'll explain where I got my numbers from. We always want to start with the side and the angle opposite that I know. I don't know the side opposite of 100, and I don't know the side opposite of 47, but I do know the side opposite of 33, and that's what tells me where to begin. So I know that the sine of 33 over 12, if I were to divide that, is the same thing as the sine of 100 over x. X meaning the side opposite of 100. You could use whatever variable you want, I just tend to stick with x. Now we are going to do some cross multiplying. When I cross multiply, this is what I get. The sine of 33 times x is equal to the sine of 100 times 12. Now there's a lot of different ways students do this. I'm going to suggest that you kind of let the calculator do the work for you. What I mean by that is instead of typing in sine of 100 times 12 and getting a very icky number, I'm going to type in all that's right here at the same time. So I'm going to type in the sine of 100 times 12 divided by sine of 33. When I do all that, I get my solution that x is equal to 21.7 meters. So just simple cross multiplying. It's kind of similar to what we did before, where we had to actually divide to solve. Now the last step is pretty similar to before. Now I know two different side lengths. I still prefer to go with the one that I was given, because if I were to solve this one incorrectly and I didn't go back to this one here, I could possibly get the wrong answer. It's better to stick with what was already given to you. So I stuck with sine of 33 over 12 meters equals sine of 47, remember that's the angle we found, over x. Now x is now the side over here. I followed the same steps, and it actually looks quite similar to what I had before because I was given angles. Given the angles, it's actually a lot easier to solve these triangles. Like with the last problem, I would suggest that you just use your calculator to type in all of this section right here. I would type in the sine of 47 times 12 divided by sine of 33. You really don't need to be bothered too much with parentheses either because your calculator follows the order of operations, so it will multiply and then divide. That gives me this length here. What's great about law of sines is you can kind of check your answers by seeing what makes sense. We already know from when we did Pythagorean theorem that the side opposite the right angle was the biggest because the right angle was the biggest angle. The same thing should apply here. I have an angle of 100 degrees. The side across is 21.7, which is the longest side of the three. 33, which was the one that was given, was the smallest angle, and it has the smallest side. 47 is not that far away from 33, and so that side is just a little bit bigger. It really does make sense how those numbers work, and it's just an easy way to make sure your answer makes sense. Now this is probably the easier triangle question. Again, like I suggested, it might be a good video to watch everything and then watch it again and maybe a couple times just to see where all the steps come into play. In my next triangle, these are the problems that I have a feeling we'll need to spend the most time with in class tomorrow. I think we'll have to spend a little bit of time on the first problem, and that's totally understandable. But this problem is the one that will cause the most trouble because finding the missing angle gets sloppy. And I do plan on going through a problem like this in a little bit more detail. But by previewing this video, you're getting yourself a little bit ahead of the game. Step one is we need to see the missing piece. Remember, it's a side, the angle opposite, a side, the angle opposite. So I am trying to find this angle because it's opposite the side I know. I don't have two angles, so I can't find the third angle that easily, and I don't know the angle opposite the missing side. So how I would set up this problem is I would say that the sine of 52 over 17 equals the sine of theta, or whatever variable you would like to use, over 14. We do the same thing with cross multiplication. Sine of 52 times 14, sine of theta over 17. We need to isolate sine of theta. So what I want to do is I want to divide both sides by 17. Now, this is my preference, but again, you can type everything in as you go. Once I get this section here, sine of 52 times 14 divided by 17, I prefer to take the inverse sine of that whole thing in the calculator. So I would type second sine, the parentheses open up, sine 52 times 14 divided by 17. I think you can see where these become difficult. You have to be very careful where your parentheses go. And like I said, we will spend some time on this in class tomorrow. Just as a rule of thumb, angles are always rounded to the whole number. So when I get this problem here, I know that 41 degrees is my angle opposite the 14. Just looking at the problem so far, that should make common sense. 17 is slightly bigger than 14, so the angles are close, and 52 is slightly bigger than 41. Now, once I know this angle, the easiest thing to do is find the third angle by using what you know about triangles. When I do that, I come up with that the angle up here should be 87 degrees. When we keep going, now we can kind of get to the easier sign that we did in the last problem. I again went back to what I was given in case I made a mistake in step 1 and step 2. Again, this is just a way to make sure that you're correct. When I do sine of 87 times 17, and I divide it by sine of 52, I come up with that x is 21.54. Looking at the angles and the sides, that makes reasonable sense. The biggest angle is across from the biggest side. The smallest angle is across from the smallest side. That will always be what happens if you find the correct answer. Now I have two your turn now questions, and what I did is trying to help you. It's probably going to be a little difficult to begin with to figure out what sequence to do things in. So what I have here on both sides is I did give you hints as to the order in which I would solve each problem. Now this first one matches example 2. I would suggest if you don't understand how to solve example 2, don't worry about doing this one. I would give this one a try just to see if you're on the right track, and we can discuss it tomorrow.